Hello, my fellow listeners, my fellow chemistry students, my fellow learners, professionals of chemistry, or whoever you are listening to this video, anywhere in any part of the world. Greet you specially. Look at this topic. You are seeing physical absorption and chemical absorption. I will be doing justice to it. I will explain physical absorption, chemical absorption. These are actually the two major types of absorption. So I will explain it and you will understand. Okay. If you have been having problem with it, this is the end of confusion. Okay. You will no longer be confused. This is today we end the confusion about physical absorption, chemical absorption. Let me go straight to physical absorption. Okay, here I go. Physical absorption is also known as physisorption. Okay, it's also known as physisorption. There's no need to be confused. It's just physical absorption. Now, let me explain this. I have already explained what absorption is. There is a video I made. The title of the video is Absorption, Adsorbate, Adsorbent. Go and look at it. It is simply the adhesion of molecules, gaseous or liquid molecules on the surface of a solid. You have a solid surface like this, and there is gaseous molecule or liquid molecule on the surface of this solid. Okay, we call this process adsorption. Adhesion of molecule, concentration of molecule on the surface of a solid. This is a solid. This process is called adsorption. And I told you this the molecule that is being adsorbed on the surface of the solid is called the adsorbate. Okay, watch the video. While the solid that receives the molecule is called the adsorbent. Okay, you can watch the video, you have understanding. And now, what do we now mean by physical adsorption? Look at me. When you have a solid, when you have a surface, okay, a surface like this, which is a solid surface, okay, and a gas molecule is held on the surface of the solid. Let me just use this as gas molecule held on the surface. This is a surface of the solid. Okay, so when a gas is held, is adsorbed on the surface of a solid by a van der Waals force. Van der Waals force is a weak force. By a van der Waals force or forces without forming any chemical bond between the adsorbate and the adsorbent. So it is called physical absorption. I come again. When a gas is held on the surface, these are gas. Let me call this gas. For example, CO2 or hydrogen or nitrogen gas. Okay, if a gas is held on the surface of a solid for any of these gas, okay, and is held on the surface like this by a van der Waals force, meaning that as it is deposited on the surface, the force it could only bring out is a van der Waals force. So the force holding this molecule to this adsorbent medium is a van der Waals force. Okay, it means that in this kind of absorption, a chemical bond, a strong chemical bond is not formed between the adsorbate and the adsorbent. So we call this kind of absorption a physical absorption or simply physisorption. Okay, a process where a gas molecule is held on the surface of a solid by van der Waals forces without forming any chemical bond between the adsorbate, this is the adsorbate, and the adsorbent. Okay, so because the gas molecule the gas molecule is being held to the solid surface by van der Waals attraction or van der Waals forces. Okay, some author call physical absorption van der Waals adsorption. Van der Waals. Okay, van der Waal adsorption. Okay, van der Waal. Okay, adsorption. Okay, you should understand why it is called van der Waal adsorption. Okay, so that is what refers to our word physisorption. Do you understand that? In physisorption, it means that the the this kind of absorption can easily this kind of bond, the weak bond can easily be removed because it is a weak bond. Okay, and the temperature that is holding this molecule to the surface is usually very low, so it occurs at low temperature. And because the force holding the molecules on the surface of the solid is very weak, it's a weak van der Waal force. Okay, because of that, physisorption or physical absorption is a reversible process. I hope you understand that. And in physical absorption, what it can only form is a multimolecular layer. Okay, and it does not actually require activation energy. Okay, let me give a better in short. Beside, I told you about that the temperature in physisorption is low, and because the temperature is low in physisorption, we can say the heat of adsorption is usually very small. Okay, because it occurs at low temperature, in that case the heat of adsorption which will also be very low. I hope you understand. So let me quickly go to chemisorption. Before I go to that, the isotherm or an isobar, absorption isobar, isotherm you can create for physisorption is usually like this. Okay, you have x over n against t is usually something like this that usually common. So this kind of isotherm describe a physisorption. Let's go to chemisorption now. So exactly the way I explain physisorption is the same way chemisorption goes. Okay, the difference is just the type of bond. Now, chemisorption is also called chemical adsorption. Okay, when you have a solid surface like this is a solid surface called the adsorbent. Please always use the right word. This is the adsorbent, the solid support, the solid surface is the adsorbent. Okay, when a gas, whether let me call this a gas, these are gas molecules. Okay, this gas molecule, they could be CO2, it could be hydrogen gas, it could be what? Nitrogen gas. This adsorbent could be a charcoal. Okay, could be a charcoal, it could be a nanoparticle. Okay, it could be a carbon dot. Okay, it can be any solid surface with a good surface area. Okay, so now if you have these are gas molecules on the surface of this solid. Okay, if they are able to form a strong chemical bond, we call it chemisorption. So when a gas molecule is held on the surface, a gas molecule is held on the surface of the solid by forces similar to those of chemical bond, by the type of force that is similar to those of chemical bond, we refer it to chemical adsorption. Okay, so we can say in this kind of adsorption, the gas molecule or atoms are held to the surface of the solid adsorbent by chemical bond. I hope you understand that. So that means this will form a bond here. Okay, a bond will actually be formed here. This bond makes it that it is a strong bond, and it has formed. This is chemical adsorption. So if by diagram they want you to differentiate, you are required to differentiate if it's option a chemisorption by a sketch. This is okay, but you must give this one a name. This is the gas molecule, you call it the adsorbate. Okay, so when the interaction between the adsorbate and the adsorbent, okay, brings up a chemical bond, you call it a chemical adsorption. So in terms of absorption, the diagram I gave there is also good, but in that one, a strong bond is not formed. It's just a weak bond. And because of that, we call it physical adsorption. And do you know, because this bond is very strong, a strong chemical bond is formed, okay, between the adsorbate and the adsorbent. It means that chemisorption will take place at a high temperature. You should understand that differentiates it from a physisorption. And that means that before you can break this bond, it will be a bit hard, it will be a bit difficult. So it means that this is an irreversible process, okay? Unlike the physisorption that is reversible, because the bond holding the molecule and the surface together is very weak. And here, it can easily form a monomolecular layer or a monolayer. So while physisorption go for multi-layers, then chemical adsorption go for multi-layer. While physical adsorption does not require any activation energy because the bond is very weak. Chemical adsorption requires activation energy, and it is very important. I told you that the temperature at which physical adsorption occurs is usually low, but in chemical adsorption it occurs at high temperature, and because of that, the heat of adsorption in physisorption is low, the heat of adsorption in chemisorption is high. Look at the tabular differences here. So you can see that physisorption and chemisorption, the tabular differences. So as I have explained earlier, so while it is reversible in chemisorption, it is irreversible. Okay, it is an irreversible process here. Okay, why this is caused by van der Waals, this is caused by chemical bond. This takes place at low temperature, this takes place at high temperature. Because of the low temperature, heat absorption is low, here heat absorption is high. Here physisorption forms a multi-layer, okay, chemisorption forms a monolayer. Activation energy is not required here. Here, activation energy is required. Why? It is linked because of the strong chemical bond. So, activation energy. Here, it is very weak. So, you may not really need activation energy to cause that absorption process. While it is reversible here, it is irreversible here. I gave you something that I want to manage this space. Okay, for physics option, you have an isotherm that comes like this for physics option as S over M versus T. Okay, I hope you can see this very well. Okay, meanwhile in chemisoption, you have an isotherm. Okay, that goes this way. Let me put X over M versus T. So the chemisorption goes this way, okay? And of course, you should know that an absorption process is an exothermic process, okay? Absorption is actually an exothermic process. So you can see this, please understand, okay? I'm bringing it up now. Understand that the isotherm that comes out from chemisorption, it comes this way, okay? It comes this way. When you see something like this, you know that a chemisorption has taken place. This is what you use and I said to describe a chemisorption process. I want to believe, listener, that you do understand this topic. And actually, I've seen many questions on this topic where the students are required to differentiate physisorption and chemisorption based on some certain parameters. Okay, the parameters could be based on reversibility, the parameters could be based on the type of bond, the parameters could be based on temperature, the parameters could be based on heat of adsorption. So most time they give it parameters with which you bring up your differences. So this actually has explained all that. If you know you understand what I've just explained, why don't you like and make comment on my video, okay, and subscribe to my YouTube channel, and also share to others, okay, so that this video can go, okay, wide, and everyone can watch it, so that we make chemistry simple to our children. We make chemistry simple to our young adults in the university, colleges of education, polytechnics, monotechnics. We make chemistry simple to those who are finding it difficult. This video is out to make chemistry simple for you. So please help me share to others, and God bless. My name is Akpeji Honesty. Thank you.